Okay, now if you're tuning in, it would be under Physical Science, November 1st, B. All right. So as we're doing this, did we set up the fraction correct? Did we? Because we listed all of our variables that we knew, correct? That we knew there's a resistance force, there's a resistance distance, there's an effort force, then there's an effort distance. Because we wrote that down, correct? Some of you you're nodding your heads yes. Okay. So if we are pushing or pulling with 1,800 newtons of force, is that resistance or is that being an effort placed to move that up the inclined plane? Yeah, you put an effort into that. So then if it's measured in newtons, you can disregard this one and you can disregard this one. Why is it only those two possibilities? Because what are forces measured in? Newtons. So this has to be a force because of that label. And you said correctly that you're putting that much effort into it, 1,800 newtons. Okay? Now, because of gravity here, the height of that ramp, okay, so gravity is pulling down on that because of the height, okay? So that's providing a resistance for that. So with that, if this is providing resistance, is that a resistance distance or an effort distance? Okay, because of gravity pulling down on that, and that's causing a resistance, is that a resistance distance or an effort distance? You got a 50-50 chance. Because this is measured in meters, right? Don't we measure distances in meters? Right. So that must mean it either has to go here or here. And if this acceleration of gravity is applying 1.20 meters of resistance, is that a resistance distance or an effort distance? It's a resistance distance. That's right. So that will go right here. Now, we placed this here, this 1,800 newtons. You're saying that we're applying that 1,800 newtons going up this ramp. So for how long are you placing that 1,800 newtons in there? Be the length of the ramp, correct? So when you do that, there's only one other place that you can put that variable, and that is which. Is it going to be a force or is it going to be a distance? It's going to be a distance because it's measured in meters. I'm sorry, I don't have the labels down on here. That was probably given that picture that I had read from yesterday. So 25 meters. Okay. Now, we have one variable left to go, but if this is kilograms and this is meters per second squared, that's labeling what two variables. If something is measured in kilograms and something's measured in meters per second squared, that's a mass and acceleration. Why is that so important? Because what can you get from mass and acceleration? Yeah, you can get a force, and that's what we're looking for right here, okay? So with these two numbers, what will you do with them according to your formula for force? You're going to multiply them, okay? So 1210 times 9.8, okay? 1210 times 9.8, 1185, no, 11,858. 11,858 newtons. Okay. Once you have it to right here, okay, according to your formula, what numbers are we going to put up top here? Because maybe it's maybe a little more familiar with this, because this is based off of what your formula was. Okay, we're just not putting the brackets or parentheses around there. So what number goes here according to that formula? What's your resistance force? Effort. 11858. Okay, so then what is your resistance distance? Okay, that is 1.2. Okay, what is your effort force? 1800. That's why having this set up and documenting where these variables belong, it makes doing this so much easier. Yes, I understand that getting this here is probably difficult. It probably is, but it's the first time that we've seen something like that. That's why it's difficult, okay? Think of, for you volleyball players, think of the first time that you started, you maybe used to serve like this. Now, what was your serving like when you did overhand? And for some, yeah, it was just fine. It was perfect. Maybe it was, maybe it wasn't, okay? And maybe shooting basketballs, okay? Maybe you didn't start at the same height that it is now. How high off the floor is the standard basketball hoop? 10 feet. So you might have learned shooting at an 8-foot hoop, or maybe even smaller. So what might that have been like when you start shooting at a 10-foot hoop? Might have been a little more difficult, okay? Now, the last one, because I think you can visualize this, okay? Think of when you first started shooting free throws. Did you jump when you shot free throws, when you were in 5th and 6th grade? A little bit. Do you jump now when you shoot free throws? Some might, and some might not. But why are you getting better at shooting free throws? Because you've practiced this. This is really no different. We're challenging your mind, okay? That's what we're doing here. Now, that last variable is what? What is your effort distance? "25 meters, okay? So now that we have that, what do we do with the top two numbers since they're next to each other? Okay, so now our efficiency equals, we're going to take that 11,858 and multiply that by 1.20. And we get 14,229. 14,229.60. That's these two multiplied each other. So we got to do the same thing here. 1,800 times 25. That gives you 45,000. Okay. Last thing, what do you do with those two numbers? You divide them. So what do we get for a number? .32 or 32%. Okay? Remember we said yesterday, I don't know what your ladies volleyball record is. We just made up the number 27 and 5. Okay? So when you calculate percentages, those do not have labels to them. So you take the total number of games you played, which was, according to yesterday's standards now, 27 and 5. Okay, that gives you 32. 32 games total, and if you won 28, 28 gets divided by 32, and it just gives you a number. That is your winning percentage. Okay, and again, I know we're just trying to understand this, and we are trying to do our best to explain this to you, okay? And the reason it might seem a little more difficult is because it's the first time that you've seen this, okay? All right. Can we erase this? Okay. Yes. No. Okay. On your formula sheet, okay, well, you can use any variable that you want. You could even do something like this. You could say B equals force over X if you wanted to. Any variable just stands in for a number. You can use any letter that you want. We just choose to do the first one, so it just makes it easier to see and differentiate. Because, okay, that means pressure. Okay, so if we're talking about pressure, it's measured in, what do you suppose F is? No surprise. Force. And then, so when we look at this, I think this room is symmetrical. If it isn't, we're just going to say that it is. Okay? If we need to know how many tiles we're going to put on this floor, we would measure this distance, and we're going to say it is 20 feet. Then we go this distance, and we see it's 20 feet. What happens when you multiply 20 because of how wide it is and 20 with how long it is? What does that give you? Length times width. Do we know? That gives you area. Okay? So this is what we're talking about. Now, I'm just drawing this, and I understand it's not a perfect box. Okay? If it is 20 feet in this direction, and if it's 20 feet in this direction, what's the square footage inside of there? What'd you say you did with those two numbers? You multiply them, and that gives you an area equals the length times the width. Okay? So in this case, area equals 20 times 20, and then you can do this in your head. You don't need a calculator. What's 2 times 2?
4.
And then how many zeros do you have? So that means your area is 400, not feet, a little more specific. What happens when you multiply? Sorry? Okay? So if we have 20 feet this direction, 20 feet that direction, and if we're calculating an area, okay, length times width, when you take any foot times another measurement that's done in foot or feet, what do you do with the two variables? I know you've done this in algebra, you just haven't, or even in middle school math. Area is always going to be measured in what? And not just feet, we've got that. Say that again. You were right. Someone said it. Oh, maybe I didn't. I could have swore I heard someone say square. Square feet. So approximately this room has 400 square feet to it, because you multiply the length of the room from the front to the back and how wide it is, and once you do that, that gives you 400 square feet. Okay? The reason we're doing that as an example, what similarity do we see between these two? I understand the numbers are different. The labels are different. Okay? So this is meters squared, and this is feet squared. Our main idea behind that is when you take length times width, it gives you an area. So what do you suppose this is a variable for with the A? Since it's measured in square meters. If this is square feet, this is also an area. So what happens to this here then? It's also an area. Okay? Because it's measured in square meters instead. Okay. So what had happened is, remember when we were doing this project, okay? So maybe this will help us out here. Here was that top piece of plywood. Then you had a bottom piece of plywood. Okay? And then you had these 4 wooden dowels. Okay? And then you had this structure right here. Oops. And what did we call this right here? It had a specific name.
Keystone.
That was your keystone. Okay? And that's what we see here. So as you were putting more and more weight on here, some of you maybe had, what was it, maybe 70 pounds? Okay? We'll just say 70. Okay? And with this, we're going to say it's 110 kilograms. So it's a little more than maybe what some of you might have had. So all that weight down on there is causing this to put pressure on that keystone. Okay? So what we see happening here is you have a certain amount of weight because of the mass, and gravity has an effect on it. So it is compressing that arch, and it causes that to have pressure on it. Okay? So one of the things that you can do that, and this will either think this is really cool, or you're going to think this is really, really gross. So, man, I know you just can't wait. Okay? How many of you have ever had to deal with livestock that may have had an abscess on it? Abscess means infection with what's inside of that abscess, either on their leg. More commonly, it's probably on their neck. Or it could be in their feet. We're just talking about their neck here. That infection, it's something that's probably really, really gross. And us as humans, we have this too. It's in smaller amounts. It's what causes acne. And then it gets infected. And then that acne causes what on your face? Anybody know? What are these little spots that might form on your face? Pimples. So acne just means that you have in the pores of your skin, they become infected. And when that happens, pus starts to form inside of there. So you may be standing in front of the window and you like to squeeze those and let them go shooting in every direction. I don't know. I just thought you're either going to think this is really cool or really gross. I don't know which one. Okay? So, for those of you who possibly deal with this in livestock, you take, I'm guessing that's what you do. That's what we did. You take a scalpel, some sort of blade, you stick it underneath that abscess and pull the blade back. Once you cut that open, there could be a little pressure in there, and that pus comes shooting out of there because there's pressure inside of there. Pressure just means something is being exerted. In this case, that infection is exerting on the skin. So you relieve that pressure by cutting it. Okay? So what about, how many future lifeguards do we have in here? That sound familiar? Cardiac, pulmonary resuscitation, right? So in order to do that, what are you doing on someone's chest? These are called what? Chest compressions. Why is it called that? Because what are you doing to their chest? You are putting pressure on it. Okay? Those are, we okay over there?
Yeah, great.
All right. So when you compress something, you're putting pressure on it. That's all that means. Okay.
What is the label for pressure?
Okay, pascals.
Pascals?
Yeah, why don't you let me get to that point, okay? All right. So, what type of variable is this? Okay, I'm doing my best. I'll just write the stuff up on here, and it's recorded, and you can go back and watch it. Does that sound fair, or you want me to explain it to you? I mean, yes, you have that option to go back and watch this. We're not restricting you of anything. We're still giving you the content. It's whether you want to receive it in real time or not. Is that a fair presumption? Okay. So if you see this variable is measured in kilograms, that must be what type of variable? Mass. That has not changed. So mass equals 110 kilograms. Okay? Now, since this is pressing down and we're talking about weight, what gives objects weight on this planet? Gravity. So does that gravity have a specific value? 9.8 what though? Okay? Because once we have a mass and acceleration, what can you calculate? Yeah, you can calculate the force because that's what's needed in this problem. Okay? So, we don't know. We have one more variable we haven't accounted for yet. What is this measuring? What does it tell you? Right here, it has an area of 1.72 meters. So that is why I don't care what variable you use. If you don't want to use an A, give me another variable. We can use A now. Okay? If you put a line over it, put a line over it. That's just what I do. And if you don't want to put a line over it, you don't have to. Okay. So then, okay, what is our area? 1.72. Okay? So, what is the question ultimately asking? What is the pressure? So, what two things do we need to know to solve for pressure? And whatever this thing is, what do you suppose that is right there? Okay? All right. We're going to take 110 times what? Okay? And then we'll leave that up to you to solve. Okay, pressure is measured in pascals. Okay? Forces are measured in newtons, and area is either meters squared or centimeters squared. For our purposes, if in the problem you're given square centimeters, keep it in square centimeters. If it's given in square meters, keep it in square meters. So 110 times 9.8 divided by 1.72 gives you what? One 10 times 9.8 divided by 1.72. 626.74 pascals. Okay. Okay, we were going to have a paper signed, but I think we will hold on to that until tomorrow. And don't forget that question came up. It's also on our schedule. What did it say about yesterday's schedule? Not besides machines, what else? Okay, so which is when? Which is Friday. Okay, you also have an evaluation on Friday. We'll hold on to them until tomorrow. All right, we'll catch up to you next time.